This is problem number 2 from section 3.3. In this problem, they say write the expression in standard form. Again, they're talking about the standard form for complex numbers. And the standard form from complex numbers is a plus bi. So we have -6 plus 8i squared. So we're going to go ahead and distribute that. So the first thing I'm going to do is I'm going to write this as -6 plus 8i times itself. This is very important because a lot of people screw this up because they try to just square the -6 and square the 8i. No, this is the thing that's being squared is this binomial, so you got to write it out, binomial times itself. And then you can start to distribute. So we can say that that is -6 times -6, which is 36. -6 times 8 is minus 48i. And then 8i times -6 is also minus 48i. And finally we have 8i times 8i, which is plus 64i squared. Now we're going to simplify this, and I'm going to pull back in what the complex numbers stand for here. I is root of -1. I squared is, obviously, root of -1 times itself. Radicals cancel, you're left with -1. I cubed, right, same thing. You end up with this being -1. -1 times root of -1. Well, we know root of -1 is I, so it ends up being -I. And then the last one, you end up with -1 here and -1 here. When you multiply those, that's 1. And then it just repeats itself. So I to the 5th power will go back to being root of -1. Well, we have I squared. We also have these two i's. Well, these i's we're just going to leave as so. But this I squared, we can write it as -1. So we can say equals 36 -48 minus 48. That's -96 I plus 64 times -1. That's -64, so we get 36 minus 96i minus 64. And 36 minus 64 gives you the -28 minus 96i. And so that is our solution. That is our solution to this problem, is -28 minus 96i. This is the real part, right? -28 is the real part. The imaginary part is -96i.